Hello again and welcome back. My name is Michael Fudge and this is Learn to Program in Java Lesson 13. We're picking up where we left off in Lesson 12 and we're talking about arrays. This time we'll be looking at the multi-dimensional variety of arrays. As usual, we'll start out a lesson by explaining the concept behind a multi-dimensional array and how it works and why you'd want to use it. Then we'll get into two demos. One will just be a basic demo of how to index and enumerate a multi-dimensional array with nested for loops. And then the second demo will start to build out a tic-tac-toe game solution. It ought to be fun. The important thing to remember is that a multi-dimensional array is just like a regular array. The only difference is that there's more than one set of indices. These are useful for representing two-dimensional and three-dimensional structures like maps and game boards and matrices and cubes like this one. As a matter of fact, if you look at the code at the top, I've declared a variable called cube with 3 dimensions. That's why there's 3 sets of brackets here. And at any given indice of my dimension, I'm holding an integer. And so I'm declaring this cube to have 3 integers in each dimension. And then I've represented my cube here graphically. Remember, when you say int 333, it's declaring an array that starts at 0 and ends at 2. So that's 3 positions inclusive starting at 0. All arrays in Java are zero-based arrays. For example, when I say cube sub 2, 0, 1, that's like saying go down to position 2, stay at position 0 here, and then just go up 1. And then I'm setting that value to 9. So the value 9 is at position 2, 0, 1. Now, why is 9 on both sides of the cube? Because this is not a Rubik's Cube kind of puzzle. What it really represents is this physical block in here has the value 9. So for example, the one above it has 3 faces that you see, 1, 2, 3, but really it just gets one value. The value would be at 2, 0, 2 in that case. Let's try another one. How about cube 1, 2, 1 gets the value 5. So we go over 1, up 2, over 1 again. That's where the value 5 goes. Let's think of another example. This one's a little more real world. How about a tic-tac-toe board? Everybody knows the game tic-tac-toe, where you have 9 spaces. It's a two-dimensional grid of size 3. So there's the Java that makes my tic-tac-toe board. I say string array board equals new string of size 3 and 3. So I have 1, 2, 3, and then in those sub-indices I have 1, 2, and 3. And now I can place values on the board simply by indexing various elements in the array. For example, I'm placing an X at position 1, 2, row 1, column 2. Or maybe I'm placing an O at position 2, 0, row 2, column 0. So you can see how a two-dimensional array makes it very easy to represent real-world structures such as boards and maps. Let's get on to some demos. First thing I'd like to do is demonstrate in Java how you can create a two-dimensional array, set values into that array, and then use a nested for loop to enumerate all the elements out of the multi-dimensional array. Then from there, we'll get into a real-world example where we try to create a tic-tac-toe board. Should be fun. Okay, here I am in my NetBeans IDE, and you can see I have my main method, and there's no code that I've written so far in this main method. And what I'd like to start out by doing is showing you that up above I've created a two-dimensional array grid with various characters in it. And what I'd like to do is write code that fills up my two-dimensional grid to match my picture that I have in lines 9 through 15. So first thing I need to do is declare my array, and I think I'll just call it board like it's some kind of game board. And rather than using strings, I'll use characters to just show you something different. So I'll say character array of 2 dimensions. I'm going to call it board. It's going to be a new array of size 3 in both dimensions. Now, do both dimensions have to be the same size? No, I could make 3 rows and 10 columns if I want, but for this particular implementation, I'll keep them both the same. Next, I'm going to start assigning values in my array. For example, the X is at position 0, 0 up here. So let's do that. Board 0, 0. That gets a character X. Then right in the center we have a W, so let's do that next. That's at position 1, 1. And how about board 2, 0? That's going to get an X. That's right here. Board 1, 2. That should be an O. And board 2, 2 is our last O. Now, in the same way that I debugged the one-dimensional array, I can debug the two-dimensional array. And what I'll do now is I'll set a breakpoint here. And then I will step into this code and just run it up to that breakpoint. And then if you look at board, it says it's a two-dimensional character array. And you can see it has indices 0, 1, and 2, which are in turn character arrays. And when I open up, for example, board 0, I see that it's X, empty, empty. If I open up board 1, it's empty, W0. And that kind of matches what I did here. X, empty, 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 W0. See how that works? All right, let's take a look at how you can enumerate through an array. Now, if I did something like this, I'm not showing you anything you haven't seen before at this point. And if I said board I, that would refer to the row, right? So board 0, board 0, board 1, and board 2. But I need to access both elements in the array. So to do this, I'm going to need a nested for. I'm going to have a for, and then inside that for, I'm going to have another for loop. I'm going to use a different loop control variable here, j. And this time, I'm going to be able to access the individual elements in the array. I'll be able to say something along these lines. Let's get fancy here. I, j, and then board I sub j. I probably want to put, that's good. And then for reasons that you'll see in a minute, after this for loop completes, I've now printed out this row. So now I need to move down to print out the next row. So I'll just simply do this. That should move me down. All right, let's run it, see what happens. There we go. So I see 0, 0. Let me roll it back up again. At 0, 0, I have an X. And then empty, empty, then empty, W0. Then X, empty, 0 in that last line. If you're missing out on what's going on, what I'll do now is I'll run it, we'll hit our breakpoint, and then I'll step through it so you can see how the for loop produces this output here, just to make sure you actually got it, see what's happening. So here we go. I'm going to hit debug. Now I'm going to hit F8 to step through it. F8. And we're going to look at the output the whole time. So there we go. X, see that? Blank. Blank. Move down a line. Blank. W. 0. Move down a line. X. Blank. O. Move down a line. Done. Pretty simple. I hope you see at this point that multidimensional arrays are really no different than the arrays you already know. The only difference is that there's another set of indices. So you can have two-dimensional, three-dimensional, four-dimensional arrays. It just depends on how many arrays you want to nest within the other array. Typically, we have two- and three-dimensional arrays. They're not uncommon. In the next example, we'll leverage the power of the two-dimensional array to make a tic-tac-toe board. Okay, in this next example, we're going to, as I said before, we're going to make a tic-tac-toe board. So what you want to know about a tic-tac-toe board is it's a two-dimensional array, and at any position on the board, we're not going to place a character or a string. We're going to put in our own custom type called a marker. So the first thing we want to do is make that marker type, and then we want to make an array of markers. So let's get at it. Here I am back in the NetBeans IDE, and I created a new project. I just went up to File, New Project, and I created a new Implementing Tic-Tac-Toe project, and I have an Implementing Tic-Tac-Toe Run Java in there. What I'm going to do first is I'm going to make a package, because I want to keep the code that's associated with the tic-tac-toe stuff separate from the package that I already have here called Implementing Tic-Tac-Toe. I'm going to make a package, and I'm going to call the package Tic-Tac-Toe. Doing this is how you end up making your code more reusable, because this package is going to make its own jar file, and I'll be able to take that jar file and use it in other projects once I know the code inside Tic-Tac-Toe works the way I expect. So I want to make a class here. I'm going to call this class Marker, and you can see that the Marker class is inside the Tic-Tac-Toe package. And this is how I'm going to define my Marker class. I'm going to make an enum. And what I want to do here is I want to say, an X is going to be the character X, and an O is going to be the character O, and empty is going to be a space. These are my three values for the type marker. So I'll be able to say marker.x, marker.o, marker.empty to determine the conditions of my board. Because my enums have values, I need to define a constructor for that and a private member. So private char ch marker char ch. This character gets the parameter that you pass in. And then how about everyone's always good for a toString override. And here I want to say return string dot format. Let's format that character from this character. So this is a way to take that character and convert it to a string. And I got to fix this. There. Beautiful. So now I have this custom data type that I've made called marker. It has three values, X, O, and empty. When you use empty, it always uses a space. When you use O, it always uses O. When you use X, it uses X. And then I've overridden toString so that it becomes very print friendly. If I say marker.x, it will print out an X. If I say marker.o, it'll print out an O. Marker.empty, it prints out a space. Beautiful. Let's make our board. So first things first, when I make a board, I'm going to need an array to hold that. So a board is nothing more than a two-dimensional array of marker. Think about that for a minute. Let's go back and look at our screen. We have a two-dimensional array, and the only thing we can place on this array are markers. Yeah, I know I've defined it as string here, but I think I'm going to get more mileage out of using marker, and you'll see why. Let's make our constructor. When we go into public board, we should say this board is new marker of size 3s. And we should always initialize the board, so how about this clear? Now I haven't written clear yet, but I'll write that in a second. It might also be handy to construct the board by passing in an existing board, right? So I can say board X equals new board, and then play with that board, and then when the board's full, I can say board Y and then assign it the value of X through the constructor. So I'll override the constructor like this. And this time I'll pass in an array of marker, and I'll call this the board, just to be a little different. And what I'll say is this board equals the board. So again, this second constructor allows me to take one board and then, in essence, make another object from that existing board. Back up to this clear method. Writing clear should be pretty easy. Let's write it now. I think I want to capitalize clear. So what it means to clear the board is to make every space on the board empty. So let's do it. Remember, we learned before you're going to have to use the nested for construct. So I won't bore you with all the typing, but you're going to need something like this. You're going to need that. And then, for each row, And then for each cell in that row, I want to say this board ij gets marker.empty. And that should clear my board. And it's kind of important that if you define an empty board that you clear the board. So what else might I do to my board? Well, I might draw the board, right? Public void draw. And this should print out my board. And what might this look like? Well, again, we're going to need that. As I showed you in the other example, right? This is the common practice to get around a two-dimensional array is to use a nested for loop. So I told you I'd be using a couple of these. Now I could just be lazy and do this, system out print board ij, and then down here system out println. But this is going to print out a really lame looking board, mainly because it's missing all the wonderful vertical and horizontal lines that we see in a normal tic-tac-toe board. See my little cross lines here I've got, right? And it also might be helpful to print out the cell number. So I know that this is cell 00 and this is cell 10 and this is cell 22. I mean, that's kind of useful, especially if you're going to make a game out of it. I'm going to have a little more stuff here, and what I'm going to do is I'm going to put the code in here and then explain it to you. It's probably easier than watching me type all this in. Okay, there we go. So the first thing I'm going to do is print out my header of 012, just like I had on my board here. Then I'm going to print out the equivalent of each of the cells with one or more spaces and lines in there. Then I'm going to move down a line and repeat. And when you're done, you're going to end up with a really interesting looking board. So what I want to do is let's show you what board draw looks like by going to implementing tic-tac-toe. And let's say board game is new board. And of course it doesn't know about board, so I'm going to hit Control-Shift-I. And it's going to import from my package tic-tac-toe my board. And then let's just say board draw. Or I'm sorry, game draw. And let's execute that with F6. So there's my game board. As you can see, I've got 012, and then for each row I'm listing out the row index, and then here's my individual cell pieces in the board. So it's a pretty fancy board. Let's write a method that lets us place a marker on the board, because that's what we're really going to need in order to make a legitimate game. Let's go back to board Java, and let's write a method. Public, let's call it a Boolean place. And then what are we going to place? We're going to place a marker. And we're going to place it at int row, int column. There's probably 150 ways we could write this method. Do we check to see if they put it in? What if I put row 17 in here? It should have a problem with that. For now, I'm just going to let the system just crash if I put in a bad row and column. Later on, in a future lesson, we'll learn how the proper way to address this using exceptions. But for now, let's just take it as fact that the user is going to do the right thing and give me a valid row and column. So we might say something like this, right? At the simplest level, you say this dot board at row and at column. Set that to marker. Boom, done. And then I'll just be silly and say return true. Okay, this is probably the dumbest implementation of how to place a token on a marker, because one thing it doesn't check to do is see that there's something already there, right? But let's run it just so you can get a feel for what happens after we go in here and start placing some things on the board. So let's say game draw and then game dot place. Let's place an x at 1, 1. And then, since you don't want to watch me type, it can be painful. How about we place an O at 2, 0. And then how about we draw the board again? Bingo. Well, it's not bingo. It's tic-tac-toe. Well, you get my... Hopefully you got that joke. Let's run it and see what happens. So up here, there's my empty board. Then I placed my X marker at 1, 1. And I placed my O marker at 2, 0. Now, as I said before, my place method is not ideal because there's nothing that would prevent me from placing, after I draw the board, from doing this. Game place. Let's place an X at 2, 0. This would normally not be a valid move in tic-tac-toe, right? Because I just overwrote O's move with X's move, and this is just not how the game is played. Let me show you what happens here. I'm going to run that. And you can see I have my X here and my O there, and then I do a place the marker X, and then I have replaced it. So I need to have some logic in my place method, and let me just do that as a last step. How about if that position is marker empty, then place the marker. So you can only place it there if it's empty, and then we'll return true, else return false. So I like this a little better because this implementation at least handles a situation where someone tries to place a marker over somebody else. It doesn't really do anything with it. It just says true or false, and then, you know, the person that calls the place method needs to address that, right? So game place, I would have to check if game place returned true before I did something else in my game. Again, as you see in a future lesson, we'll discuss this in more detail. But let's just see when we run it now if it still overwrites the X over the O at position 2, 0. It should not do that. Let's check it out. So there it is. And then I place the marker at 2, 0, and then it's still that because my logic inside board Java says, you know, if it's empty, place it. If it's not, just go back, return false. Later on, again, we'll handle this by throwing a custom exception, which is probably the most appropriate way to handle a situation like that. Hopefully this gives you a really brief introduction to how to handle two-dimensional arrays and what their value might be, especially in a game that involves a two-dimensional structure like a game board. I encourage you to look at this code and trace through it, step through it a line at a time using step into and step over so that you can get a feel for how a two-dimensional array is enumerated to draw this game board here and to place items on the board as well. Also, in my source code, I have more methods that I've implemented beyond just place and draw. You might want to check those out. And as part of the challenge activities, you actually implement a complete tic-tac-toe game right down to checking when you have 3 in a row. It's actually pretty cool and interesting, and it's a great way to not only learn how to problem solve, but also how to use a two-dimensional array. Well, thank you so much for taking the time to watch this lesson. I appreciate your comments and feedback on YouTube, and we'll see you next time. Once again, thanks so much. Bye now.